Bismillahirrahmanirrahim. In this video, we are going to look at the concept of pointers, particularly pointers in C++. So far, we have been looking at variables. Now, variables are names. So when you define something like int x is equal to 5, so x is the name given to the location where 5 is stored. However, if we look deeper into the concept, we find that there are other things as well. There is something called the physical address, and then we have the concept of pointers. So pointers are a powerful feature of the C++ language, because with pointers we are able to control the locations of variables. We can reference them, we can dereference them, we can assign the address of one variable to another, and many other things that are not possible using simple variables. But at the same time, it is rather tricky to master the concept of pointers. So hopefully in this video we are going to look at enough examples, and I'm going to have an analogy, so hopefully you will have a better understanding of what pointers are by the end of this video. So C++ basically allows two ways of accessing variables. The first one is the name of the variable, and the second one is the direct access. It is the address or the pointer. So to access the same location, you have two ways. One is the name, and the second is the actual address. So for instance, if you are in a GIK, if I tell you that go to GIK Institute, so I have told you the name, and you will arrive at this university or this institute. The other thing I can do is I can say, okay, go to plot number 5 and I don't know, Right Bank Road, Topi, and if you go to that address, you are going to also arrive at the same location at the same GIK Institute. So here the name GIK Institute is actually the name, whereas the address plot number 5, I'm just giving an example, it's not actually 5, but plot number 5 and Right Bank Road or Topi Road, that is the address or the pointer. So they will both land you at the same location, and whatever is inside the institute is actually its value. So when I write something like int x is equal to 5, here x is the name. This name is, like I said, GIK Institute. This is the value, and apart from that, apart from these two, the name and the value, there is also the address, like I said, 5 Right Bank Road. So this is the address, which will also point to this value. So x is basically a nickname for that address, because it is easier for me to remember x rather than remembering the address. So it's easier to say GIK Institute rather than say go to plot number 4 Right Bank Road. So in C++ we use the simple symbol ampersand, the AND symbol, to get the address of a variable that follows it. So if you recall, we have used this AND, but we used two of these consecutively. So I write if x is equal to 5 and y is less than 3. Here this is an AND operator or symbol. Here, however, I am using a single ampersand and not two ampersands. So this is different from this. Don't confuse the two. This is the combination here is a completely different thing. It is not this symbol repeated twice. It's a different thing. So the address or pointer can be displayed by the cout statement. So there's a possibility for me to display the address where this x is actually pointing to, and that will be displayed in hexadecimal. So it is going to be in base 16. Usually it is something like 0x and ff and something like that. That's how it's going to look like. It's a hexadecimal number. This is a simplified example of what a memory would look like, right? So here we have the void main in which we define int data equal to 100. So here data is the name of the variable. Data is the name of the variable. However, this is a type integer. It means it's going to have 2 bytes. So it's going to be stored somewhere. That location is, let us assume that the address of that location is FFF4. So it's a hexadecimal. It's using base 16. You have the value numbers 0 to 9, and then A, B, C, D, E, and F. So this is an address in hexadecimal notation, and the name was difficult for me to remember this, therefore I give it the name data. So data basically refers to this address, and the value stored here is 100. So this here is the value, and this here is the name. What is hidden here is the address. There's actually an address that is that this name refers to, and where this 100 value is actually stored. Similarly, for float, I can have a variable called value, whose value is 56.67, and if I want to actually write these addresses, so these two, what I need to do is I can write cout data. So when I say cout data, it's going to give me this value 100. If I want to write the address, I'm going to write cout ampersand of data, that is the address of data. So the address of data is going to give me FFF4, which we see over here. So 100, that's the value, and this is the address. This is as a result of data, and this is as a result of ampersand data. Similarly, for value we have this, and for ampersand value we have this address over here. So that is the concept of pointers. Now let's look up the pointer data type. Let's look more in detail. So the pointer is also a data type. Here we are just giving detail about the simple variables that we have been using so far. Here I haven't created a pointer yet. I'm just saying that the simple variable I created, data, has also an address which I can refer to using the ampersand symbol. There is something also called a pointer. So a pointer is a data type. What is a data type? Just like you had int, you had float. These are data types. So a pointer is also a data type, and it's a data type for containing an address rather than a data value. So a variable where instead of writing 100, I am going to write the address where this 100 is written. If I look at the previous example, basically I am saying I am going to write this. What's the address where this 100 is written? FFF4. And how do you access that? Ampersand of data. So it's a variable that will store the address rather than storing the value. So it's similar to the int data type or the float data type. The size is the number of bytes in which the target computer stores a memory address. So the target computer, depending on which addressing system you are using in your computer, the size is the number of bytes that is used to store the memory address. And it provides an indirect access to the values. So I can still, because it is a pointer that is storing an address, I can still go to that address and look what is stored there. So I can still access the value, but now I'm going to do that indirectly rather than directly. This is how the syntax of a pointer looks like. So the data type will be the type of data which I am for which I want to store the pointer. So the data type here can be integer, can be float, can be double, can be character, or any other thing. And this asterisk here along with the name, so this is the name of the pointer, and this asterisk denotes the fact that this variable is not a normal variable, rather it is a pointer variable. It does not mean that asterisk is part of the name of the variable. No, it's not the part of the name. the name of the variable is pointer var name. This asterisk just simply denotes that the pointer variable here is it's a variable that can contain a pointer. It cannot contain a value. It means I cannot put pointer var name equal to 100. That's not going to be possible. But I can write a pointer var name equal to FFF0. That will be possible. So it can contain a address but not a value. The pointer variable is used to point to a value. The asterisk before indicates the pointer, and it's not the regular variable, but it's rather a pointer, but it is not part of the name. So here we have an example. Here I am defining the variable ptr1, and this asterisk denotes that this variable is a pointer variable, and int means ptr1. It's a variable that will contain the address of a location that can contain int. So कोई int variable होगा, कोई जगह होगी जहाँ पे हम int स्टोर कर सकते हैं, उसका जो एड्रेस है वो ptr1 में स्टोर हो सकेगा. तो ptr1 इज इक्वल टू 10 नहीं कर सकता मैं, लेकिन अगर x इज इक्वल टू 10 है, जो कि x एक इंटीजर है, तो वो जो x का एड्रेस है उसको मैं ptr1 में असाइन कर सकता हूँ. Same goes for the float or any other data type. So it's a pointer to an int value. It can have the address of the memory location or the first of more than one memory location. For instance, more than one memory location, for instance an array allocated to an int value. ptr2 is a pointer to a float value. So let's look at some examples. White spaces don't matter here, and each of the following will declare ptr as a pointer to a float variable and data as a float variable. So I can use either this notation, or I can use the other notation, and in both cases it is going to have the same effect. What will be that effect? That ptr will be a pointer to a float variable and data will be an actual variable. So I can, whether I use the brackets or I don't use it, it doesn't matter. It's going to be the same thing. So let's look at another example. So to illustrate what we are trying to say over here, the differences between all these pointer and address and pointer and whatever. So if you have been to Islamabad, there is a rather large building called the Centaurus Mall. Now let's assume that this is my memory location here, and assume that the plot of land on which the Centaurus is built, I can put some value there. Maybe I can put the value 5 over there. Now what's the address of this place where the value 5 is put? Let's assume it is in the Centaurus Mall. So here I'm going to write the address. So the address is 4 and Jinnah Avenue, right? So 4 Jinnah Avenue is the address where the Centaurus Mall is located. So if I want to go by address, I can use this address. I'll arrive at the exact same plot where the value 5 is stored. If I want, I can simply write Centaurus, and if I refer to that, it's also have the value 5. So I can write int Centaurus equal to 5. It declares a variable called Centaurus that has the value 5. If I want to see out Centaurus, the result will be, it will output 5. If I want to see out ampersand of Centaurus, it will see out the actual address. So 4 and Jinnah Avenue. If I want another name associated with this. For instance, if I want to call it Islamabad Mall or something like that, or just with some value X. So what I can do is, if I want to create a pointer, then I will write int asterisk. This is a pointer. Now this PTR, if I try to write PTR is equal to 5, this is wrong. PTR is a pointer, it cannot contain a value. 5 is a value. What I can do, however, is PTR is equal to ampersand of Centaurus. Now what is PTR? PTR is pointing to this address. So if I want to write what is the value of this address, तो ये एड्रेस का नाम मेरे पास क्या है, ये PTR आ गया मेरे पास, बराबर मैंने कर दिया, असाइनमेंट कर दिया. अगर मैं देखना चाहता हूँ कि इस एड्रेस पे वैल्यू क्या पड़ी हुई है, तो आई कैन राइट सी आउट asterisk of PTR. When I write C out asterisk of PTR, PTR is a pointer. Asterisk means the value of. एक तो asterisk multiplication के लिए यूज होता है. This is another usage of that asterisk for pointers. When I write C out, let me write this clearly so that you can understand. Let me write C out and asterisk and PTR. So what this is saying is, I can write it like this, or I can write it with the braces or with brackets, it doesn't matter. What I'm saying is that what I want is the value corresponding to whatever this pointer is addressing to. This is a pointer PTR. This is not possible. It cannot address, contain a value, but it can contain an address. That address is 4 Jinnah Avenue. When I say asterisk of PTR, PTR की वजह से मैं यहाँ पे जाऊँगा इस एड्रेस, asterisk की वजह से कहेगा इस एड्रेस पे वो क्या चीज़ रखी हुई है, तो वो 5 रखा हुआ है. इसके नतीजे में अब मुझे 5 आ जाएगा. So there are four things that we have used. One is the value, second is the variable name, third is the variable address, and fourth is the pointer. So यहाँ पे pointer जो होगा मेरे पास, अच्छा pointer भी इसी तरह का एक variable होगा, उसका नाम जो है वो ये होगा, और उसके अंदर value क्या पड़ी होगी, उसके अंदर जो value है वो ये यहाँ की value यहाँ पे पड़ी होगी इसमें. So like that. So that is how we are going to conduct this, how we navigate through these pointer values. So I hope it is clear with this example that the 4 things we are dealing with, the data itself, the variable name, the address, and the pointer. So there are 4 different things. And if I want what is the address, अब ये भी तो इस तरह होगा ना, जिस तरह ये था, इसका एड्रेस था, एक वैल्यू थी. ये जो PTR है, इसकी जो वैल्यू है ये 4 जिन्ना एवेन्यू है. PTR का अपना एड्रेस भी होगा एक. If I try to write C out this, so whatever is in this place that will be output. क्योंकि PTR एक वेरिएबल है, इस वेरिएबल का एक अपना एड्रेस भी होगा कि ये चीज़ कहाँ पे स्टोर है, PTR खुद कहाँ पे स्टोर है. PTR ने स्टोर क्या किया है, वैल्यू क्या स्टोर किया है, एक एड्रेस स्टोर किया है जो कि यहाँ पे ले जाता है मुझे, और इस एड्रेस पे क्या चीज़ है, वो वैल्यू पड़ी हुई है 5. So if you can understand this picture, you have understood the entire pointers. That's why I tried to use this board to perhaps try to explain how the things are working. So let's look at a couple of examples. So a pointer variable has to be assigned to a valid memory location, and so float data equal to 50.8. So data is a variable. Float asterisk PTR, and PTR is equal to ampersand of data. So this is a pointer, it must contain an address, and here we are assigning it the address of data. So this will assign the address of the memory location allocated for the floating point variable data to the pointer variable PTR. This is okay since the variable data has already been allocated some memory space having a valid address. डेटा एक वेरिएबल बन चुका था, इसका एड्रेस था, वो एड्रेस मैंने ptr को असाइन कर दिया. This is how it's going to look like. So when I say float data equal to 50.0, so at some location, for instance FFF4, I will get this 50.8. When I write float asterisk ptr, एक नया वेरिएबल ptr के नाम से क्रिएट हो गया जिसका अपना एड्रेस क्या है, FFF0. It means that if I were to जो हमने अभी पहले देखा था स्लाइड में, if I try to see out ampersand of ptr, this should give me this. So this is going to give me FFF0. And the third one is ptr equal to ampersand of data. So this value over here is assigned to the ptr. So ptr actually now refers to this data, or the value of ptr is this address, और इस एड्रेस पे जाके क्या वैल्यू आएगी वो एस्टेरिक ptr से मुझे मिल जाएगा. इफ आई राइट सी आउट एंड एस्टेरिक ptr, सो ptr में ये पड़ा है, ये एड्रेस. एस्टेरिक ptr का मतलब ये कि इस एड्रेस पे जो वैल्यू है, ये एड्रेस ढूंढेगा कहाँ पे है, वो यहाँ पे है, उसमें वैल्यू क्या है, वो ये है. तो इसके नतीजे में आपके पास क्या होगा, 50.8 प्रिंट हो जाएगा. Don't try to assign a specific integer value to a pointer, since this can be disastrous. So if I write float asterisk ptr and ptr is equal to 120, basically what I'm trying to say is that 120 is an address that is being assigned to ptr. Now that's not going to be possible. It can be disastrous. So instead what I'm going to do is float asterisk ptr, I'm going to write the address of data. I can assign an address but not directly a value. And just like if I declare something, so int x, now x is going to have a garbage value. If I write int x, instead I prefer writing int x is equal to 0, so I am initializing it as well. Here you can also initialize the pointer, and to initialize the pointer you use the null value. So float asterisk fp float pointer equal to null. This means that it won't be having a garbage value, but it is initialized to what is called the null. And null is not 0, but it's specific to pointers. So the null pointer is a valid address for any data type, but null is not memory address 0. So it is just used so that you, for instance, if you want to write a while loop, so while you want to while ptr not equal to null, maybe you are assigning something, and when you want it to stop, so when while ptr is not equal to null, so null is a value you can use. It's a valid address, but it's not necessarily the memory location 0. It is an error to dereference a pointer whose value is null. So when I put int asterisk ptr is equal to ampersand of data, this is creating a pointer and assigning it the address of the variable data. When I say cout asterisk ptr, it means go to the location stored in ptr and show me its value. This is called dereferencing a pointer. So ptr was the pointer. Using this asterisk to get the value of that location is called the dereferencing a pointer. So such an error may cause your program to crash if the pointer points to null and you are trying to dereference it. So you are saying basically null location पे जो value है वो बताओ मुझे क्या है. So there is no such thing. So this may cause your program to crash, and it's the programmer's job to check for this. So आप कभी एक ऐसे वेरिएबल को जो नल को पॉइंट कर रहा है उसको डीरेफरेंस करने की कोशिश ना करें. अगर करेंगे तो उसके नतीजे में आपका प्रोग्राम क्रैश हो सकता है, या it will behave erratically depending on the compiler, how you are doing with it. So dereferencing, we did see an example, but let's look at it in a more formal way. So dereferencing is using a pointer variable to access the value stored at the location pointed to by the variable. So this is an indirect way. The pointer stores a location and you're saying, okay, go to this location and tell me what's the value over there. So this is an indirect way of printing the value. And it is done by the dereferencing operator asterisk put in front of the pointer variable. It's a unary variable. It means that unlike plus or minus, so if I have a plus b, the plus operator usually requires two variables a and b, so that I can write a plus b. Here the asterisk one is as unary operator. Just write asterisk ptr. आपको एक ही वेरिएबल चाहिए होता है, तो उसके ऑपरेशन के लिए दो नहीं चाहिए होते. And it has the highest precedence. So if you are trying to multiply, divide something, or brackets or anything, asterisk is going to have the highest precedence. So let's look at this example. Float data equal to 50.8, float asterisk ptr. So this is a pointer to a type float. ठीक है, ये पॉइंटर है, लेकिन किस चीज़ का पॉइंटर है? एक ऐसी जगह का पॉइंटर है जहाँ पे फ्लोट वैल्यू स्टोर हुआ करेगी. ptr equal to ampersand of data. ptr is a pointer. You cannot have a value, but you can have an address. Using ampersand, you get the address of data and you assign it to ptr. And then cout ptr will give you 50.8. So once the pointer variable ptr have been declared, asterisk ptr represents the value pointed to by ptr. And the dereferencing operator asterisk can also be used in assignments. So asterisk ptr equal to 200. It means go to the location pointed to by ptr and put its value to be 200. So you can use that in this way as well. Asterisk ptr, anything that is a pointer, if you write the asterisk notation with it, it means you are now essentially making it a sort of a variable, because you are saying go to the location and whatever you need to do with the value. So make sure that ptr has been properly initialized. Otherwise, if you're trying to do this kind of an operation, then it might result in an error or even the program crashing. And finally, the last example for this lecture is this diagram, where we have a set of code and we are showing how it works in the memory. So the memory has several locations and possible places for the values. So when you write a float data equal to 50.8, data में 50.8 जाके स्टोर हो जाएगा. उसके बाद ये हमने साथ ही लिख दिए यहाँ पे कि float asterisk ptr की वजह से ये ptr बन गया, और ptr is equal to ampersand data. इसमें ये fff4 जो डेटा का एड्रेस था, क्योंकि आप एम्परसेंड डेटा करें तो डेटा का एड्रेस जाके इस पॉइंटर में स्टोर हो गया. सो द करंट मॉडल इज बेसिकली शोइंग द एग्जीक्यूशन ऑफ दीज थ्री स्टेटमेंट्स. नाउ यू आर ट्राइंग टू सी आउट ptr. एक वेरिएबल जब आप सी आउट करते हैं तो उसकी वैल्यू सी आउट हो जाती है. ptr की वैल्यू क्या है? ptr की वैल्यू ये एड्रेस है, ये सी आउट हो जाएगा आपके पास. इसके नतीजे में आपके पास ये चीज सी आउट हो जाएगी पहली. सेकंड, asterisk ऑफ ptr. अब वो कहता है इस एड्रेस पे जाओ और जो वैल्यू है वो सी आउट करो. इस एड्रेस पे जाओ तो यहाँ पे जाएंगे, यहाँ पे वैल्यू क्या है? 50.8. सो इसके नतीजे में 50.8 होगा और इसके नतीजे में fff4 हो जाएगा. सो द आउटपुट विल बी fff4 50.8, which is shown over here. So at the result of this cout statement, you have these two values printed. The ptr is fff4 and asterisk ptr is 50.8. Next, you are changing the value. You are saying asterisk ptr is equal to 27.4. So essentially you are saying go to ptr. Ptr is this. Go to this address, which is this. The content of this is going to be 27.4. Basically the content of this. So ये आपका खत्म होगा. Your content is now 27.4. and then do the same thing, cout ptr and cout data. So once you do that, इसकी वैल्यू चेंज हो गई. और cout asterisk ptr क्या था, ptr पे जाओ, एड्रेस है, उस एड्रेस पे जाओ, उसकी वैल्यू प्रिंट करो. इसके नतीजे में क्या होगा, 27.4 प्रिंट हो जाएगा. और cout डेटा करेंगे तो डेटा सिंपल आप डेटा करें तो वो भी 27.4 ही होगा. तो दोनों के केसेस में आपके पास 27.4 ही होगा, चाहे आप पॉइंटर के थ्रू जाएं या आप डायरेक्टली डेटा के ऊपर चले जाएं. So this is the concept of pointers in C++. I hope with the several examples that we have used in this video, it should be clear. Basically we have four things: the value, so this is the variable, this is its value, and this is its address. This is a pointer, this is the address of the pointer, and this is the value of the pointer, which actually is also an address, because that is what pointers are for. They are there for storing addresses. And after that, this is a simple notation what to do. If you write cout data, it should give you this. If you write cout ampersand of data, it should give you this. If you write cout ptr, it should give you this value. If you write ampersand of ptr, it should give you FFF0. If you write asterisk ptr, it should go to FFF4 and look at what is the data, which is 27.4, and cout 27.4. So just to summarize this, cout data, this is going to give you 27.4, and just imagine everything here is in cout. Ampersand of data, this is going to give you FFF4. If you try to cout ptr, this is going to give you again FFF4. If you write ampersand of ptr, so ampersand the location of this ptr, this is going to give you FFF0, and asterisk of ptr, go to the location ptr and give me the value. So go to the location ptr, which is this, give me the value. This is going to be 27.4. So this is the entire concept of pointers to the level that we are going to study in this course. So I hope it's clear with these examples, and if you have any questions, we can discuss it during the interactive session next week. So I'll stop here, and hope you enjoy this video.